such that liquid surface in tank is below the top edge of opening. It is made of a metallic plate used to measure small discharges through the small channel and tanks. The bottom edge over which the liquid flows is known as sill or crest. Notches and sheets, they are known as the liquid flowing over a notch is known as nappe or vein. Type of notches. Notches are classified according to the shape of the opening, like rectangular, triangular, trapezoidal, stepped. According to the effect, notches with end contraction, notches without end contractions. Now, features of notch. Features of notch means it can only be provided in the side of a tank. The sheet of the water coming from the notch is known as nappe or vein, used to empty a tank, used to measure small discharges. Bottom edge is made sharp to reduce friction. Features of an orifice. An orifice can be provided in the side or at the bottom. Sheet of water coming from an orifice is known as jet, used to empty a tank completely, used to measure very small discharges. It may or may not have got the sharp edges. Then discharge through a rectangular notch. So, this is a rectangular notch having the length and the depth. An opening of a rectangular shape is known as a rectangular notch. If this is a rectangular and this is the notch, and then it is known as a rectangular notch. If CD is the coefficient of discharge, then the actual discharge is equal to coefficient of discharge multiplied by theoretical discharge. Then the discharge is equal to, we are getting this formula, it is equal to 2/3 CD 2G the under root L H raised to power 3/2 power. There is a small example. A rectangular notch 3 meter wide, constant height 600 mm. Find the discharge over the notch if coefficient of the discharge is 0.62. We take the formula. The discharge is equal to 2/3 CD, 2G the under root L H raised to power 3/2. So, in this equation we have got the solution is, in this case the length is given, H is given, coefficient of discharge is given. Now, in this equation we substitute coefficient of discharge. We put length of this G 9.81, H which is given to be 600, that is 0.6 is substituted 3/2, and we calculate the results. Then discharge over a triangular notch. Then we come to, this is a triangular notch, this is the angle theta at which it is made. It may be a right angle, then theta becomes to be 90 degree. So, this is a triangular notch. An opening having the shape of a triangle is referred as a triangular notch, as from the shape. It is also known as a V notch. So, V notch is preferred to a rectangular notch when the discharge is to be measured slow. So, from this formula we calculate discharge is equal to 8/15 CD 2G the under root tan theta by 2 H raised to power 5/2. Now, there is a small question. Find the discharge of a triangular notch having the angle that theta is 60 degree when the head over the triangular notch 0.4 meter and the coefficient of discharge is equal to 0.61. So, we take solution, angle of notch theta, height which is given, the coefficient of discharge. Then the question is, then the discharge is equal to 8/15 CD 2G the under root tan theta by 2 H raised to power 5/2. We substitute CD, G 9.81, tan theta by 2 and H which is given 5/2. We take its value and calculate so many meter cube per second, and we multiply with this, this comes out to be so many liters. Then we come the next article, advantages of a triangular notch over a rectangular. The value of only H is calculated to be taken for measuring the discharge. The formula becomes very simple for 90 degree notch, that is discharge is equal to 1.417 H raised to power 5/2, which is easy to remember. Triangular notches give more accurate results of the low discharge, and the other points Then we come to the discharge for trapezoidal. So the trapezoidal is made up of the two type of notches. One is for rectangular, and this combination of these two is a V notch, that is a triangular. So the discharge, this becomes the combination of the two formulas, that is for a rectangular notch and for a V notch. So this is discharge in case of trapezoidal is equal to 2/3 CD 2g the under root L h raised to power 3/2 plus 8/15 CD 2g the under root tan theta by 2 h raised to power 5/2. Then we come discharge over a stepped notch. So this is a stepped one. So in this case we calculate for portion 1, then portion 2, then portion 3. These are the rectangular type. These are the rectangular notches. So in this case, the equation is the sum of the discharges through the different rectangular notches as we have calculated earlier. So for this one, the head is H1. The second one is we take this value. We take this value for H2 and subtract for H1. So for the third one, we take the total for this value and we discharge for this from the height H2. We calculate for H3 and subtract for H2. So the formula it becomes, it is equal to the first one plus second one plus third one. So that is equal to 2/3 CD 2g the under root L1 H1 raised to 3/2 plus 2/3 CD 2g the under root. So L2 remains the same. So the height H2 minus H2 the 3/2 minus H1. So this H2 minus, because for the total calculated we have to subtract this one. So this is H2 raised to 3/2 minus H1 raised to 3/2 plus this third segment. So third segment we calculate its total value. So we have to subtract this one. So it means that 2/3 CD 2g the under root L3 H3 raised to power 3/2 minus H2 raised to power 3/2. Then we come to the Weirs. So Weirs, according to the geometry of the weir, discharge conditions, width of the crest, nature of the crest and the end conditions. So according to the geometry of the weirs they are classified rectangular weir, triangular weir, trapezoidal weir, straight weir, concave weir, convex weir. So these are the examples of the rectangular. This is for triangular weir, this is for trapezoidal, this is a straight one, this is a concave one, this is a convex one, because it is the convexity. This is the convexity. Then according to the discharge conditions, free weir, ordinary weir, drowned or submerged weir. So this is an example of the free weir, the liquid is flowing free here. Now this is a drowned. Drowned means जेड़े हमारे पास ये weir हमारे बनाया है इसके ऊपर से हमारे लगे, that is known drowned. Then according to the crest, narrow crested or broad crested. So this is for a narrow, this is a narrow one. The weir which we have made it is of a very small thickness, that is a narrow one. Now this is a broad crested. In this case a weir is of a broad crested. Then according to the nature of the crest, sharp crested, oggy weir. So in this case the weir which we have made, it has got a very sharp crest. Then we come the oggy. Oggy means this type of the shape we are getting to here for the weir. Then according to the end conditions, then suppressed weir or the weir with the end contractions. So this is the suppressed one and this is a contracted weir. So this is the weir which we have got contracted one. So from the total width we are getting to minimize by certain factors, that is a contracted. Then certain features of the notch. Features are usually made of in plates, notches and weirs के अंदर. Notch is of a small size. Water passes through the notch. The edges of the notch they are sharp and thin, used to measure small discharge, and the base length is small. Then we come the features of the weir. Weirs they are made of masonry or concrete. Weir is of a bigger size. Water flow over the weir. In that case through the weir, but through the notches, but over the weir is there. So notches के through but weir के ऊपर से. The crest or sill of the weir is wide, used for measuring huge quantity of discharge. The base length is large. Then we come to the next article, discharge over a broad crested. So, this is a broad crested weir. So, a weir having a broad crest is called a broad crested weir when the width of the crest is more than h by 2. The width of the crest is more than h by 2. So, this is the head. So, when we say that this width is more than this h by 2, then this is known as a broad crested, and the discharge formula of this is equal to 1.71 coefficient of the discharge length h raised to power 3 by 2. Then the measurement of discharge by velocity area method. Now, let us say we want to measure the discharge by velocity area method. In non-uniform channels, that rivers and streams where notches and weirs cannot measure discharge, then velocity area method is used. So, in this case what we do is सिंपल सेगमेंट मेथड के अंदर जो टोटल डिस्चार्ज हमारे पास होगा, सो इट इज इक्वल टू L1, so it is equal to L1 D1 V1 of the first segment, then second segment, then third segment, fourth segment, fifth segment and the sixth segment. So, the total discharge would be L1 D1 V1 plus L2 D2 V2 plus L3 D3 V3. Then measurement of discharge by the second method, which is a velocity area method. So, this is the Simpson's rule is here applied. The width of the river is divided into a number of even segments of equal length and depth of the water at each segment is measured. So, the discharge in this case formula is becomes equal to, so what we do is we divide the width of the river is divided into a number of even segments. Even segments matlab this is 1, 2, 3, 4, 5 and 6. We have divided into even number of segments. Now, then how we can find the discharge? By a Simpson's formula. It would be equal to first plus last 2 times the odd plus 4 times the even, we close the bracket, multiplied by L divided by 3. So, Simpson's formula de naal the width of the river is divided into a number of even segments of equal length. This is for the equal length. Segments हम even के अंदर इसको distribute करते हैं. Then we note its depth and it note its velocity in the segment. We note its depth, we multiply with the velocity. So, depth, the mean one, and the velocity by any method, by current meter, Peter tube or floats. So, the discharge is equal to first plus last 2 times the odd plus 4 times the even multiplied by L divided by 3. Thank you, please. So, in this case we have studied the various factors of our topic of the flow measurement. Thank you, please.